All right, today we'll cover subsetting. Subsetting is something that R does very well, and it's very powerful and very useful for lots of applications. And so we've got to discuss the rules. There's a few things that you've got to learn to make sure you got a good handle on this the subject. So we'll spend all of today talking about subsetting. So first, we'll talk about subsetting atomic vectors. Okay. So here I've got a simple vector x. It's got some numbers in there: 2.1, 4.2, 3.3, and 5.4. The spot after the decimal, so the 0.1, 0.2, 0.3, 0.4, that kind of indicates where it is in the original vector. Okay. And we'll cover all of these methods for subsetting a vector using either positive or negative integers, logical vectors, and character vectors. I think most of you are familiar with subsetting atomic vectors already, but we'll cover it here. All right. So as far as the positive integers go, it just gives you back the exact positions, right? So if I say I want the third and the first elements, it gives me back the third and the first elements indeed, 3.3 and 2.1, okay? Order will tell you how you should subset the vector so that the vector is in order from least to greatest, okay? And so when I say order x, it says if you want the x vector to be in order, pick the first element, then the third, then the second, then the fourth. And when you do that, indeed, it goes in order from least to greatest. The first element's 2.1, the third element's 3.3, second element's 4.2, and the fourth element is 5.4. If you specify the same index multiple times, R has no problem, and it will give you back the same element multiple times. So here if I say subset x giving me 1 and 1, it gives you back the first element in multiple times. Okay, no issues there, right? No complaints. If you give it a floating point number, it truncates it. It doesn't round. It just truncates it and gives you back that element. So I've got 2.1 and 2.9. It truncates it to 2, and it gives me back the second element twice here, okay? For those of you who arrived a couple minutes late, I've got the attendance poll running right now, so go to onlinepoll.ucla.edu, respond to the poll, okay? I'll leave it open probably for another 5 or 10 minutes or so. All right, we can subset with negative integers, and this basically tells R, I don't want these things, right? So you say, I don't want the third element, I don't want the first element, and you get back the second and the fourth elements, okay? But you can't mix negative and positive values, because that's confusing, right? You're saying, I don't want the first element, I do want the second element, and what are we supposed to do with the third and the fourth? Do you want them? Or you don't want them? Why did you tell me you didn't want this, but you wanted this? So it gets confused. Because it's confusing. All right. I think we're familiar with this already, right? You can subset with logical vectors, and this is very handy, right? So if you give it a vector that's of the same length, it's just going to kind of do a one-to-one correspondence and give you back the elements that are true. So we've got true, true, false, false. It's going to give you back it's true for the first two elements, so it returns the first two elements. It's false for the third and fourth elements, so it gives you back nothing for those ones, right? And so here I've got a comparison statement, x greater than 3, which will return a vector of length 4. And it's going to be false, true, true, true for x greater than 3. And when I subset x using this logical statement, I get nothing for the first element, and then elements 2, 3, and 4, which is basically the elements of x greater than 3, right? And again, I'm pretty sure you guys are familiar with all of this. Okay, we do have, you have vector recycling. Okay, so if you give it a logical vector, it will recycle it. And so if you just say true and false, it's going to recycle to true, false, and that's why we get the first and the third elements here. Okay, and then if you give it a vector with a missing value, an NA, it will always return NA. Okay, as far as subsetting an atomic vector with single square brackets, we get this. All right, a couple things, special cases. If you put nothing in there, you're going to get back everything. You put in a 0, you put in a null, you're going to get back a 0 length vector. Right? So these are a few cases, right? So the nothing we often use for, like, when we're subsetting a matrix. We'll often say I want these rows, comma, nothing, to say I want all the columns. Okay, and vice versa. Okay. And then sometimes you get back 0 length vectors, right? You can set names, all right? If you set names, then you can subset using characters. So here I've named the vector x, and I've said the first element is A, and then we got B, C, and D, and then you can subset y and say I want the elements named D, C, and A, and we get that, right? We get 5.4, 3, 3, and 2.1. So we can do that with character vectors. Just like with the integer vectors, you can take the character vector and repeat it multiple times. So I've got A, and A, and it's going to give back the same thing multiple times. If you do subset using names, this has to be, the names have to be an exact match. Okay, so here I've got ABC is equal to 1, and if I try to say subset, so the name of this item is 1, the name of 1 is ABC, and if I try to subset it saying I just want A, it gives you back a missing value, right? See, it says that element is missing and the name is missing as well. Okay. All right, so a nice application of character subsetting is you can create a lookup table. All right, so here, here's our original vector, and it's got M's and F's and U's. Okay, so so maybe this represents genders. Okay, and maybe someone says, you know what? Please replace these. Okay, with the words male and female and something like that. Right. So instead of having to write some kind of function that's going to say every time you find if it's equal to M, replace it with male, and if it's equal to F, replace it with female, you can create a vector, and I'm going to call this vector lookup, but this vector only has 3 elements in it, right? It's got an M, an F, and a U. I'm sorry, actually it's got male, female, and missing, okay? And the name for male is M, the name for female is F, the name for missing is U, okay? So it's a named vector. And then I can, quote, subset the named vector with the original data, okay? And because I'm going to basically do a lookup function, or not a lookup function, I'm just subsetting this lookup vector using these names in here, it repeats everything, right? So every time we're basically saying, give me back, you know, index M and index F and things like that, and it gives you back this this vector where all the values have been filled in. Okay. And then if you want to clean it up so it doesn't have the names, it's not a named vector, you can just unname it. Okay. So I think this is very handy. So rather than trying to write a function that says if it's this, then replace it with this, you can just do create a lookup table, right? And again, it doesn't feel like we're subsetting, but we are, okay? We're subsetting where the indices can repeat and stuff. Okay, let's take a look at subsetting lists. All right, so subsetting a list is similar to subsetting an atomic vector, all right? And the important thing to note is that when you use a single square bracket on a list, it's always going to return a list, okay? So if you've got a list and you use a single square bracket, you're always going to get a list back. And if you want to get the contents of the list, you have to use the double square bracket or a $ if it's a named list, right? So if the list is named, then you can use the $, but otherwise you use the double square bracket, okay? An analogy that I find helpful came from our language tips, and this is, you can think of a list as a train, okay? A train of cars, and when you use a single square bracket, it will give you back the train cars themselves. If you use a double square bracket, it will give you what's inside the train car, okay? So if we've got a train, double square bracket 5 will say, go to the 5th car and give me what's inside. So double square bracket will give you what's inside the car, whereas X single square bracket 4 through 6 will be give me back cars 4, 5, and 6. Okay, it will be like another train, and it's another train with cars 4, 5, and 6. Okay, single square bracket 5 would be the actual car, train car number 5. Okay, so you get back another train. So you can think of, so anytime you use a single square bracket, you're going to get back a list or a train. Double square bracket will give you what's inside. Because you're going to be opening what's inside, double square brackets can really only handle one element in there. Okay, so if you can only put in one thing, because if you say look inside what's in train car 5, it might come back with a list. And if you say look inside train car 6, it might come back with a vector, right? And we don't have there's not some unambiguous way to kind of combine these things of different types. So you can't say give me the contents of multiple train cars. You can only say give me the contents of one list element or one train car there, okay? So here is just a simple example of using the double square brackets, all right? So here I've got a list A. It's got 2 cars, car X and car Y. Car X has the vector 1 through 4, car Y has the vector 9, 9, 8, 7, 6. And so here I can say double square bracket 1, this tells what's inside train car 1. It's a vector 1, 2, 3, 4. Here's double square bracket Y. What's inside train car labeled Y, and that's a vector, 9, 8, 7, 6. Okay. Here I use single square brackets, and I say give me back car Y and car X. And so now I get back a list, okay? Single square bracket always returns a list, and so now I have another train where I've got train Y, train car Y, and train car X. Okay. Here, if I try to say double square bracket Y and X, this gives me an error, okay? So basically I'm saying look inside Y, but I can't kind of combine it with something else, and so we get an error, okay? When you do double square bracket with a vector, it's actually what we call recursive subsetting, and it's saying look inside square bracket Y, and within that thing, look for element X, okay? And that there's no element X inside a square bracket Y, right? So inside double square bracket Y is this vector 9, 8, 7, 6, and there's nothing called X there. Okay, so there's nothing to return. We get a subscript out of bounds error. All right, so here's another example. This is a list a list D. It's got 3 elements in it. List A, element A is a numeric vector, element B is a logical vector, and element C is a character vector. The list single square bracket 1 gives me back a list with A, okay? It gives me back a list of length 1, okay? The double square bracket gives me the contents of that box, or the contents of that list, and that's going to be a double vector. All right. I'm going to keep hammering this for a while here, okay? Because this is a very important distinction. the use of the single and the double square brackets. So single square bracket of a list always gives back a list. All right, here is another list, okay? This one has no names, okay? So here, when we had the names for D, I'm going back here, okay? I had, the first element is named A, and so when I say give me back the first item, it gives you back kind of $A, which indicates that this is a list, all right? And that's what we see, okay? Here is, I'm creating a new list, and there's no names assigned, okay? And so the $sign is blank. And so when we subset one of these things, it's going to come back with R's list notation here, right? So if I say, give me back single square bracket 1, it gives you, it prints it out like this, double square bracket 1, single square bracket 1, right? So double square bracket 1 tells us that what's coming back to us is a list. And within that list is this vector 1 through 8, okay? Single square bracket tells us, you know, the first item is here. Here I've got, when I subset the list using the double square bracket, this gives us the contents of the first train car. That is just the vector itself, okay? So when you read R's output and stuff, okay, I don't know if you currently just ignore all of the square brackets and stuff that appear alongside every output, okay? The square brackets actually tell us important information. It tells us if the output that we're getting is a vector, okay, or if the output we're getting is a list, right? And if we just ignore this stuff, then we might not notice that this is a list, this is a vector, right? So these are kinds of the clues that appear in the output that are important to us. Okay. All right. What's happening here? I've got single square bracket 1, single square bracket 2. Okay. So basically, what we have back when I did the single square bracket 1, it's got this list. It's a list. And then I'm of one element, and I'm saying, what's the second element there? There's nothing there, okay? So so it can't give anything back, all right? So it gives me back a list with null, okay? A list with nothing inside. This, on the other hand, works, okay? This says look inside that first train car, okay? And we have that vector 1 through 8, and then the single square bracket 2 says, okay, what's the second element inside that first train car? And that's going to be the number 2, right? So we're saying subset this list, look inside, and now we've got a vector that we can work with. And inside that vector, what's the second element? It's 2. Okay. This is almost equivalent to doing recursive subsetting. If we did recursive subsetting where you are putting in a vector 1, 2, then you get, it's equivalent to doing this. L1 double square bracket 1 followed by double square bracket 2, which says look inside that first train car, and then you see a list, or not a list, you see a vector, and what's the second element in that vector? The number 2. Okay, so these two are almost equivalent to each other. All right, is that all right? Okay, so here, I am going to put that list L1 inside another list L2. Okay, so I've got a list inside of a list. Okay, so L2, what is the length of L2? The list L2. It has a length of 3, right? Okay, so you can imagine this as being, we've got 3 cars in the first train, train car 1, 2, and 3, and inside the first train car, inside this car, is another train, okay? So it's like I've put a train inside of a train, right? So I've got a train with 3 cars, and inside the first car, I've put another train of length 3 in there, okay? So how would what is my subsetting command that I would write in order to get the letter B here? how would I refer to the letter B? You can write this down on paper. You don't have to. All right, you want to say how you're going to get it? The letter B?
Double brackets, a vector 1, 2, and 2.
Okay, yeah, you can do it that way. Yeah, so double bracket 1, and then double bracket 2, and then single bracket or double bracket 2. Okay, 1, 1, 2, 2. So we're going to use a kind of a series of double brackets, or we could do recursive subsetting that way. Yes. Okay. So what we want to say, okay, what we want to tell the computer is, here you've got this train. The outermost train, L2, has 3 things, and we want to look inside the first train car. So we're going to do L2 double bracket 1. Okay. That's going to tell us, okay, inside of here I see another train, okay? And so we say, okay, now we want to look inside the second car of that train, okay? And so we're going to have double bracket 2. And then finally, that gives us access to the vector, and we want the second element there. And so we can either do a double bracket 2 or a single bracket 2, okay? So it's going to be L2, double bracket 1, double bracket 2, single bracket 2, or double bracket 2, okay? Or you could do it recursively and do L double bracket vector 1, 2, 2. So we'll take a look, okay? So so this is ours list notation here for lists inside lists, okay? So if I just say single square bracket 1, okay, it's going to say, all right, what do we have? We've got a single train car, and inside that train car is a train, okay? Right? So we got a list inside a list. So that's indicated to us by having this double bracket 1, and then to indicate that there's kind of another list inside of there, we got double bracket 1, double bracket 1, right? So this is the contents of that, okay? And then the contents of this second train car inside the first train car is double bracket 1, double bracket 2, and then finally I've got double bracket 1, double bracket 3 for the contents of the third car of the train that's inside the train. Okay? And indeed, if I ask for the structure of L21, it shows that it is a list inside of a list. Okay, and that's what we have. Okay? It's a list of 1, it's a list inside of a list. List of 1 inside that list is a list of 3. Okay, whereas the double square bracket tells us what's inside that first train car, or inside that first list element. And so we get the actual train inside, and this is a list, okay? And so it's not a list inside a list, this is the list itself. So L2 double square bracket 1 is the list itself. And so now if I want to access the letter B, or I think in the slides I've said the number 2, then we've got this, right? So double square bracket 1, single square bracket 1 gives us back this. Double square bracket 1, 1, 2 gives us an error, but then double square bracket 1, double square bracket 1 gives us the vector, and double square bracket 1, double square bracket 1, 2 will give us that second element there. Okay. So these are, this can be confusing, okay? It seems like subtle differences, but this is the difference between code that works and code that doesn't work, right? So whether you're using single or double square brackets, makes a significant difference. Okay. Did you have a question here? Or? No. You can totally ask, but so okay. Is this all good? All right. Double square brackets can also be applied to atomic vectors, okay? What it will do is, if the vector is named, it's going to drop the names, okay? So here, x is a vector, 1, 2, 3, and the names are A, B, C. Okay. When I subset it to 1, I get a named vector back. And if I do double square bracket 1, it just gives me the element 1. Okay. There's a key difference, though, between using single and double square brackets when we are looking at out of bounds or zero index indices. Okay. So here I've created x. X is just an integer vector, 1, 2, 3. Okay. And if you say, what is the fifth element in x? R comes back and says that's a missing value. Okay. So the fifth element in a vector that's only of length 3 gives us back a missing value. Whereas if I do double square bracket 5, if I say what is the fifth element, but using double square bracket, that throws an error. I get subscript out of bounds. Okay. Similarly, if I subscript using a null or a 0, I would get a 0 length vector. So if you try to subset an integer vector with 0 or null, you get a 0 length integer vector. And if you use double square bracket with a null or a 0, you're going to get back an error as well. Okay. So sometimes, I guess depending on the situation, you might want to say, I never want to accidentally select a 0 length vector or something like that, right? And so you can do this, you can use the double square bracket in your code, and that way you'll always get an error versus getting a 0 length vector. This returns a 0, if you use the single square bracket, it returns a 0 length vector, which maybe is what you want, maybe it's not what you want, okay? So depending on the situation, the single and the double square bracket subsetting makes a difference. Okay. When you apply it to a list, you get kind of similar situations here. So here's just some arbitrary list, L1 again. We've got 3 elements in it. Okay. If so L1 has a length of 3. If I say what is the fourth thing here, okay, using single square brackets, this gives me back a list with the null object inside. Okay. And if I say, and if I give it the number 4 with double square brackets, then I get subscript out of bounds. Okay. This is like a super common error, I think, that happens with loops, especially if you have a for loop. You might specify for I and x through 10 or something like that. Or maybe you got some other kind of while loop and you update your index I is equal to I plus 1 and stuff like that. And as you go through you're working through some kind of list, and maybe you're trying to subset based on the index position, you often run into this subscript out of bounds error. Okay, and that probably means your index value is either getting too big or is referring to something that you're not expecting. Okay. Or okay, here if you subset using single square bracket and null or 0, you're going to get back an empty list. So this is a train car with nothing. Okay, no train cars. Okay, empty list. And here if you try to subset with using 0 or null, you get back another error. You get back an attempt to select less than 1 element. Okay. All right, so that is list subsetting here. All right, let's talk about subsetting matrices and arrays. I think probably everyone's familiar with subsetting a matrix using multiple vectors. This is probably the most common way, but I'll cover a couple other methods here that maybe you're already familiar with, maybe not, okay? So here I've created a matrix and I'm going to name the columns A, B, and C. Okay, so I've got a 3x3 matrix, and we can select them just using different vectors. Okay, vectors for the rows and vectors for the columns. So here I give it select rows 1, 2, comma, and then and I have a blank. Right, blank means give me back everything. So Here it's going to select rows 1 and 2, and it's going to give you back everything in rows 1 and rows 2. Okay. Here I've got TFT, okay, true, false, true. This is not recommended to just use T and F. Why not? Versus spelling out true every single time. Is it, why would, so I recommend always spelling out true in all caps true and always spelling out false in all caps false versus using just the letter T or the letter F.
Could you reserve the variable now?
Yeah, because all caps true and all caps false are reserved words in R, and they will always take on the value true, always take on the value false, okay? The letter T and the letter F, when you start up R, they're not variables in your global workspace, but R has already just assigned the value T, value true to the letter T and the value false to the letter F. So that whenever you type in T, it's just returning, you know, it's just named the thing. But they're not reserved words, so you can take T and you can assign it another value, right? So you can say T is equal to 0, right? And if you say T is equal to 0, so like, I don't know, you're dealing with something with like time, right? And you say, let's start at time 0, and then time 1, time 2, and something like that. So you say T is equal to 0, and then later on you use T in some kind of logical expression. You can see how that's going to cause problems, right? Because the 0 will get coerced into a false value, and now you've got problems, okay? Same thing with false, okay? You might have the letter F, and you might assign it some value other than 0, and then if you put the letter F in a logical expression later on, it might take on a value different than 0 and get coerced into something other than false. So, anyway, just so I can get the line to fit here, I have T and F, but don't use T and F. Okay, so this says true for the first row, false for the second row, true for the third row, and then give me back columns B and A, and that's exactly what I get, okay? And then here, you can subset like 0, saying give me back none of the rows, everything but the second column, and so we get a matrix that's 0 by 2. Technically, it's not really anything, okay? One thing that R does that I think you guys have come to expect is that it simplifies by default, okay? So if you select from a matrix like one row only or one column only, it's going to simplify that result into a vector, right? So if you've got, if you have a 3 by 3 matrix and you just select one row, it's not going to give you back a 1 by 3 matrix. Or if you select just one column, it's not going to give you back a 3 by 1 matrix. It's just going to simplify it down to a vector, okay? And we'll talk about if you wanted to preserve the matrix structure, you can include, you know, drop equals false and stuff like that, and we'll talk about that a little bit later. Matrices are atomic vectors, okay, right? They're atomic vectors with a dimension attribute, and so you can treat them like atomic vectors. So here I've got a 5 by 5 matrix with the letters A through Y, and I can just say I want the 8th element and the 9th element in here, right? So the matrices, the elements in a matrix are numbered down the columns. So this goes 1, 2, 3, 4, 5. F is number 6. So it goes 6, 7, 8, 9, 10. And so the 8th element is H and the 9th element is I. And so I can say, give me back the 8th and 9th element in this matrix vals, and I get H and I, okay? All right. Okay, and then the last way is you can select elements in a matrix using basically a matrix of coordinates, okay? So here I've got 5 rows and 5 columns, and let's say I wanted to spell out UCLA, okay? What I can do is I can specify coordinates, right? So I could say I want the element in the first row, 5th column. That's going to be the U. Okay. I want the element in the 3rd row and 1st column. That's the letter C, okay? So first row, fifth column, third row, first column, okay? And then I can say second row, third column, second row, third column is the letter L. So for here, so another way to subset a matrix is by giving it another matrix of two columns, which is basically the coordinates of the rows and the columns, okay? I would say this is less common, but it does have applications, right? So you can say I want to pick out the, I don't know, you've got some kind of table where you need to pick out certain values, okay? You can subset using a particular row and a particular column this way. Okay. All right, is that okay? So this can be generalized to any higher dimensional array. So let's say I have a 3-dimensional array, okay? If I wanted to select elements from a 3-dimensional array, what would my selection matrix look like? Yeah, it would have 3 columns, okay? 1 row for each element I want, and it would have coordinates in 3 dimensions, right? So here is a 3-dimensional array. I've got 2 rows, 3 columns, and 2 layers, okay? And if I wanted to select, say, the value 3 here, I would need 3 coordinates to specify. I would say it's going to be in the first row, second column, first layer, okay? And if I want the, and that's what I have, first row, second column, first layer, okay? The element 12, okay, is second row, third column, second layer, okay? Second row, third column, second layer, and that's going to be the element 12. So this can be generalized to any higher dimensional array structure. Again, this is a little bit less common, but this method of subsetting an array or matrix does exist, where you can specify the coordinates to pull out elements. All right, let's take a look at data frames. Okay, so data frames are lists, but there's a 2-dimensional attribute, or 2-dimensional nature, right? So you can subset data frames like you would subset a list. You could subset a data frame like you would a matrix, okay? So here is just a simple data frame, 4 rows, 3 columns, and here I'm going to subset it like a matrix. I give it this statement, df $y mod 2 is equal to 0, so basically where y is even, okay? And I've got the comma here, it says basically select all the rows where y is even. So all the rows where y is even is going to be row 1 and row 3, because y is 4 and y is 2, and it selects those accordingly. You can subset a data frame like you would a list, all right? So if you think about the structure of this data frame, internally it's a list, and the elements in that list are named x, y, and z. X is a vector of length 4, y is a vector of length 4, and z is a vector of length 4. So you can just say subset that, basically that list, choosing the elements that are named x and z, okay? And so that's what we've got there. Here I'm specifying it like a matrix. I put in the comma, I'm saying give me all the rows and the columns named x and z, okay? The results are the same, okay? But it's different, right? So this is like subsetting a list, this is subsetting a matrix. When you're selecting columns, it doesn't make as much of a difference, but it does make a difference when you're selecting the rows, okay? So here, I'm going to say I want the first row and the third row, comma, okay? And so I'm subsetting like a matrix. I'm saying give me back the first row and the third row, give me back all of the columns, comma, space, okay? If I left out the comma, okay? If I left out the comma, now we are saying give me back the first element of the list and the third element of the list, okay? And this is going to be column X and column Z, right? So here I'm subsetting like a matrix, and I'm saying I want rows 1 and rows 3. If I leave out the comma, however, it's going to say, give me the first element of the list and the third element of the list, which will be columns X and column Z. So it's very important that we don't leave out the comma, okay? One distinction here, okay, is that if you've got named columns, you can say, I want just column X, okay? And when you specify you just want column X or something, it's going to preserve the data frame nature or the list nature of the data frame here, okay? When you subset using kind of the matrix notation, so here I've got give me all the rows from the column X, okay? So we might feel like these two things are the same, but they're actually different, okay? When we do this, it simplifies it and it turns it into a vector, okay? So if you do df single square bracket X, it's going to give you back the column X, but it's going to preserve it as a data frame. Where if you do comma X, space comma X, so all the rows and the column X, R is going to simplify this down to a vector, okay, which may or may not be what you originally wanted to do, okay. If you use double square bracket or the $ notation, it will always simplify down to a vector, right? Okay, so we've touched on this idea of simplifying versus preserving, okay? Simplifying is anytime R goes ahead and simplifies the output to be something different from the original input, okay? Preserving keeps it in kind of the original structure, right? So we saw this already for atomic vectors. Single square brackets will preserve names. Double square brackets will simplify and drop the names. With a list, single square bracket preserves the list in nature. Double square bracket extracts out whatever's inside the list. So that would kind of be like a simplifying behavior. Factors are a little bit of a special case for atomic vectors and stuff. And when you subset a factor, generally it will preserve the original levels. So the original levels are A and B, and even though I subset it just to the first element and there's only level A, it preserves both of the levels A and B, okay? If you say drop equals true, it's gonna drop any levels that don't exist in this output, okay? So here it says there's only A, and so the levels are only A. Okay, drops the unused levels. All right. It might feel weird to throw in a second comma into the square brackets for subsetting a matrix, but this is useful if you want to use the argument drop equals false, okay? Drop equals false tells R not to simplify the output to a vector. So here I've got a 2 by 2 matrix, 1, 2, 3, 4 in there, all right? It's a 2 by 2 matrix. And here if I say I just want the first row, okay, 1 comma, space, okay, this will return back the first row. By default, okay, R simplifies it to a vector, okay, of elements 1, 3. But maybe you want to preserve the matrix nature. Maybe you want to do some kind of matrix operation like multiplication, right? So if you want to do matrix multiplication, you need it to be a 1 by 2 matrix, okay? And so here you'd have to say drop equals false, and you can preserve it as a 1 by 2 matrix, okay? Otherwise, you might run into some issues trying to do some matrix multiplication here, okay? And we already saw this for the data frames. Single square bracket always preserves the data frame nature. Double square bracket for columns and stuff will simplify it to vectors. Okay, here's just a quick couple of questions to kind of just review. So here is a data frame, empty cars, and here's just the first 10 rows of this data frame, empty cars, first 10 rows. Okay. I'm going to say empty cars $cylinders less than or equal to 5. Okay. So what I want where cylinders is 5 or less, right? So I've got 6-cylinder, 4-cylinder, 8-cylinder vehicles. I want where cylinders is less than or equal to 5. This gives me back an error. What's going on here? Well, look at this error. What does the error say? It's saying undefined columns selected. The error is kind of cut off, but why would it say undefined columns selected? Or what do I need to do to fix this? Yeah.
Use double square brackets.
The answer is use a comma, not the double square brackets thing, okay? So what's going on here is when I have empty cars $cylinder less than or equal to 5, it is creating a true false vector. It's going to go down here and it's going to say false, false, true, false, 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 true, so on and so forth, okay? So it's got this true false vector, and I think the entire data frame has something like 30 rows, okay? So I've got this logical vector that's of length 30, and it's going to say, basically say like, okay, don't pick these columns, but pick like column 28, okay? Column 28 doesn't exist, so that's why we're getting undefined columns selected. As soon as I throw in the comma, then it will say, oh, you're talking about the rows you want to select, okay? And so now, indeed, I get the rows where cylinder is less than or equal to 5, okay? So it's just a matter of including or forgetting the comma that will make or break your code. All right, let's look at this. I've got empty cars cylinders equal 4 or 6, comma. Okay, so I've included the comma, okay? And I'm basically, now I want where the row, cylinder is equal to 4 or 6, okay? But if we look at the output, I'm getting cylinders 8, okay? So why is this happening?
6 is non-zero, so the value of this is true.
Right, so what's going on here is that this OR statement, okay, so empty car cylinder is equal 4 will be a true false vector, okay, and then it sees the OR, and it says OR 6, okay, and so R will coerce that 6 into a logical value, okay, because it's not 0, that 6 turns into true, okay, and so now I've got empty car cylinder equal to 4, which is a true false vector, or true, okay, which will always evaluate to true. So it's going to return every single row, okay? And so if you wanted to do this, you have to do something like empty car cylinder is equal to 4 or empty car cylinder is equal to 6, okay? And so now you've got a vector of true falses and another vector of true falses that will combine correctly, okay? All right, what's this? Same error as before, undefined columns selected. And again, moral of the story, don't forget your comma, okay? So makes a big difference when subsetting a data frame there. All right, we'll end there. Have a good weekend. We'll see you guys on Monday.